Welcome to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video anywhere you see it. Try as much as possible to share, and also subscribe. If you have not subscribed before, kindly press your subscribe button for direct update from us. At this point on this channel, we have over 300 videos for you to work with. You can play with 300 videos, different topic in mathematics, physics, and chemistry. It means you can come here and learn any topic of your choice and go and write any exam you want to write without no problem. You surely get them. If you want to reach us, you can comment below, or you make use of this line. You make use of this line 3480344. With this line, you can do three things with this. You can call us, you can WhatsApp us, and you can via Telegram is also allowed. Either of the three, you are good to go. On this video, I'll be walking you regression and ANOVA. We have an ANOVA table already on this channel. It means you can come and learn ANOVA table without no problem. I have something that explains ANOVA table, a video that explains comprehensively ANOVA table. But this time around, I'm talking about regression and ANOVA. The outline of this video, the first one is definition of regression, which I don't have much to say there. And number two is the connection between regression and ANOVA. You know, ANOVA is just like when you are having two or three, you are having more than two variables. That is when you try to make use of your what? ANOVA. Now, let's try to see what I'm trying to say. Now, when we talk about regression is talking about the relationship between variables. Now, regression is a relationship between two or more variables. That is what is called regression. It means regression is talking about relationship between two or more variables. That is what is called regression. Now, when we talk about regression, you have to understand what regression is. Normally, we have correlation, we have regression. Take note of that. But when we talk about regression is just like everything you have done in correlation, you also do it in regression. But regression is more deeper than correlation. The first thing, you have to know the kind of the relationship. You know, I told you that we have, with our help of our scatter diagram, you know, we have done that in our scatter diagram, that you have to have perfect positive, negative, graph is zero, relation, and so on. I can check on our video on that scatter diagram if at all you need that. Now, which I've told you about the relationship. Now, when you do that on your variable, dependent and independent. Now, what you need to know on the correlation, on the regression, the first thing you need to find, you have to find your R. Now, your R will tell you the kind of relationship. Maybe is what is negative or is positive. Now, maybe it's positive or negative. That's what your R tells us, which you have n summation of xy minus summation of x summation of y divided by root of n summation of x squared minus summation of x y squared, open, close with bracket, open another bracket, n summation of y squared minus summation of y bracket of squared. Now, this is how to find R. Now, it's just like from 1 less than equals to R less than equals to 1. It means we are talking about what? 1 minus 1 to what? To 1. In a perfect line, in an inequality line, this is minus 1. This is what? 1. I think it's 1. This one will now be what? Is 0. Now, when you have something of negative, for instance, when your value is what? Is negative. When it's negative value, like you have a negative value, what you just need to do is that it shows negative relation. If the negative is very close to 1, minus 1, like 0 point, like we have it 0 point, so minus 0.8 something something something. Now we call it I negative. I or I negative. Now if it is not, this one is I negative. Why? Here is what? Here, when you have it here, we call it very close to 1, which is my positive value. We call it a what? I positive. I positive. I positive. Take note of those things. They are very important. I can't explain everything, but I will try my best to get at least 60% of this on this part. That is very important on that one. Now, after we have done that, you know the relationship, we have this and at hand. The next thing we need to know is that we know what is called our R square. Now, my R square, just like my R squared is always equals to when you square the value of that, what you just on your relationship. Now, R squared is just like you are squaring the result of your R, which I've shown you the R, what I'm telling you now, summation of what did I call it? Summation of x, y minus summation of x, summation of y divided by root of summation of n, summation of x squared minus summation of x, close the bracket of n, summation of y squared minus summation of y bracket of squared. Now, when you have it roots like this, and you now square the result, that will become your what? R squared. Now, what R squared does is it helps you to know the coefficient of determination. Now, when you have the number, for instance, you have something of when you square your result, I'm just assuming it's not the result from. If my R square is something like this, you're having something like okay, you are having something like 0.7044. Now, what you need to do now at this point of your R square, you just have it with in your determination, just have it 70.4%. That is your what? R squared. That is your R squared in percentage. That is your R squared in percentage. After that, you can now tell shows that what 70%. The coefficient of determination is 70% of the variable in the, you can quote the variable, which is, it can be independent or dependent. Why you just move to 100 minus 74.4 all in percent. When you have it, that is your what? That is what is called, which the one that are not doing it at all. That is what that is talking about. It means you will be having 29.6%. These are the variable. This one for the what? Dependent, and this one for what? Independent. Now you have to know how to play around this. Do you get it now? It means 70.4% are doing it. I don't know what you are working on. I'm just trying to generate some variable. Why this is telling us that 29.4 are not doing it. That is what you are going to quote there. Please take note of that. Take note of that. Very, very important. Now, the next thing I want you to understand is I've talked about R squared, I've talked about R, and also I've talked about how to generate the variable. I mean, the percentage level. Now, what you need to know also, you need to know there are some things that you need to understand. Very, very important. Now, we have to understand what is called adjusted R. Adjusted R. Adjusted R squared. Now, how do I get my adjusted R squared? It's very simple. My adjusted R squared is always equals to 1 minus 1 minus r squared bracket of n minus 1 divided by n minus b minus 1. Now, you don't need to stress yourself much. Now, we all know that your r is the what? Is the what you just find finished now. I mean your r squared, which is your r squared. The n is the number of what? Rows. Or let me use number of rows. Number of rows. Now, number of rows. Now, you know what is rows like? 1, 2, 3. You know, one number of your cells. Let me use the word cell. Number of cells. Please take note of that. It can be R. I mean your N, and your P is talking about what? The number of what? Independent variable. The number of independent variable, which is if you have, we have dependent and independent, one other. Now, the number of independent, mostly it's always one. Number of independent variable, number of independent variable. Now, that is your n. That is all you need there. I've told you about r squared, which you just get it that. Now, by having this, you have done your what? Your adjusted r. Your adjusted. Now, the usefulness of adjusted r is just to let us to know the what? The standard deviation, the distance, behind the variables. Now, that is very important. That is on adjusted r. Okay, the next thing I want us to work on before we close this, we call it standard error. Call it standard error. Now, my standard error is just like standard error. Now, my standard error is just, how do I get my standard error? It's very simple. Now, my standard error is always equals to standard deviation divided by root of n. That is my standard error. That standard error is just equals to that. Now, how do I get my standard deviation of this? It will be my equals to what? Summation of s minus s bar bracket of squared divided by n minus 1 or root. That is my standard this thing. Please take note of this. It's very important. It means on your table. On my next video, I will try to put an example so that to be able to put an illustration on this part. Now, once you have that, you have your standard error as this. This one give us this, and by so doing that, just generate your result and you go. That's our standard error. Now, that is what you need to know about that. Now, the next thing you need to understand is that you have to understand your okay, please take note of that. And what else do you need to understand again? Okay, now you have to know your coefficients of these things, which is they are very, very important. The first thing is that you have your what? Normally I call it bi and b naught. Now, bi is always equals to n summation of xi 1i minus summation of xi summation of yi divided by n summation of x squared minus summation of I all squared. This is I squared. That is my what? My bi. And my b naught. My b naught is always equals to mean of y minus bi of s, which is mean of y, mean of x. Make sure you watch the next video for better understanding. I'm just stating it at this point. That is very, very important. Now, we need what is called our y cap. Now, my y cap, it always equals to b naught minus b I y. Now, this y is different from this y, and this y, they are not the same. This one is talking about mean of y. This one is talking about mean of y. Now, this one is talking about a what? Y on cells. I mean, s on, this is S of mean. This one is what? Y on cell. On cells. Now, what does it mean by cell? This is a cell 1, cell 2, cell 2. It means you'll be talking about one on each of them. It means Y cap cell, you get a what? On a row. Now, this is my X, this is my Y. For instance, the Y of YI, which means at this point will be what? XI, S1, S2, S3, S4, and so on to down part. That is how you have it. Now, after that, the summation of everything will give you what you mean by your Y cap. That is, after this, you would now, this one will now lead us to what is called ANOVA table. Now, after we have gotten your Y cap, by your Y cap, which I've told you that our B naught minus BI minus SI, after that you have gotten that, you can now go for your error. Now, all these things will be in table. The next video will really expatiate that. The next video I want to compute, which is you have to watch it for better understanding. Now, how do I get my error? My error is very important at this as far as ANOVA is concerned. Now, how do I get my error? My error equals to what? YI minus Y cap. You know what is called YI and Y cap. That is my error. My error is equals to YI minus Y cap. We have done that. My Y cap, I just stated now. Now, that is my Y. YI is the cell on each. How it comes. That is my error. Now, watch my error. My scalar error, we call it error squared. Error squared is equals to you square of your result, which is absolute value of Y cap all squared. That is my error squared. Now, how do I get my R? My regression. My regression is to be equals to Y cap minus Y mean. Y cap minus Y mean. Now, we have gotten a cell which is on Y cap. On each of them, we have Y1, Y2, cap 1, cap 2, 2, cap 3, and so on and so forth. Now, when you finish that day, it means on each mean of Y, you know what is called mean of Y? Mean of Y is summation of Y divided by number on number of the cells. Number of the cell will be what? Any number you have, that is your mean. After doing that, that is your what? Now, your R squared, which is equals to Y cap minus Y mean all squared. That is your R squared. Now, after that, you have gotten this. Now, it will be very easy for you to generate your what? ANOVA table. It will be very easy for you to generate your what? ANOVA table. How do you generate your ANOVA table? Take note of this information very well. Now, I want to generate my ANOVA table. This is how ANOVA table looks like. ANOVA table. Now, this is how it's always look like, ANOVA table. Let me put my B variable. Sorry for that. Now, ANOVA table is just like this. The first thing you have your what? Degree of freedom. This is degree of freedom. Here we call it sum of squared. Sum of squared. Here we call it mean sum of treatment, or mean sum squared. I'm permitted to mean sum squared, and this one we call it we have f calculated, and some people use p-value. Okay, let me put a p-value. Some people use f value and p-value anyhow, and you can call it what? P tabulated or tabulated, anyhow you want to. This one you can call it f value, or you call it f calculated, and this one we call it f tabulated or p value. Let me use p value. I think it's common to profs to use a p value. Now, that is what I'm trying to work on. That is all I mean by what? ANOVA table. Here, we call it what? This is, we can call it treatment variable, or some people call it regression. Some people call it here, we call it error, or some people call it residue. Let me use error. Some people call it residue. Anyhow you want to call it. Some people call it residue. Here we call it regression, or we call it treatment variable. Anyhow you want to call it. Why this one we call it total variable. Now that is how my ANOVA table looks like. Degree of freedom is always like degree of freedom. Now, this is where work is. You have to know this one very, very well, because this will tell you how it will be. Now, the first thing you need to understand, degree of freedom. How do I get my degree of freedom? Now, I can put my what? N minus 1. Now, here will be what? N minus 1. That is my degree of freedom. That is my degree of freedom. It means that if your number is 10, for instance, if your number is 10, here will be what? Will be 9. Will be 9. That is my degree of what? Of freedom. Now, the next thing is that, degree of freedom, of regression. Of regression, what you just need to do, the number of what? Of the variable, which is going to be what? The number of the variable, maybe the number of independent variable is 1. Sorry for that. Why here we call it n minus 2. N minus 2. If your n is 10, it means if your n is 10, here of error will be 10 minus 2, which is going to be what? 8. Please take note of that. I have my reason of using number like that. It means n minus 2. Now, what the last part of it? It will be sum of it. You add up this plus this, it will give you something like this. It means normally it will be 9. You know, when you add up the two, you have 9. That is, I'm just giving an example of number so that I'll be able to put it very well. Now, the next thing is that I want to find my what? Sum of square error. Now, from my table, from my table, after I've generated my table of y cap, my error, whatever I have, my summation of error squared, summation of r squared, summation of error squared, now is what I'm going to put here. Now, it means whatever I have here, it means summation of r squared is what I'm going to have here. And here, I will have summation of my error squared is what I'm going to have here. That is what I'm going to have there. That is all. Now, I will add the two together, and we have, now, here will be what? Summation of r squared plus summation of error squared. Error squared. That's what I'm going to have here. That's very good. Now, here, mean square treatment, mean square value, or when you call it. Now, ms. Now, what I need to do here is that I will divide summation of r squared divided by 1, which is degree of freedom. Let me use degree of freedom of what? Of regression, which is of this. It means I'll be having indirectly, please take note of that, indirectly I'll be having divided by 1, which is going to be repeated. That is very important. What I'll be having here, I'll be having summation of error squared divided by what? My error number, which is 8. I will have what I'm having there. Please take note of that. That is all. Also here, I'll be having this divided by this, or you add up the two and have what you need to have, which it will be summation of what? Summation of r squared plus summation of r squared, e squared all over 8. it will give you the total. Now, what you need to do here is that this is the very, very funny part of it. How do I go? This one is very, very funny. My R, permit me to rub this part of the board. Permit me to rub the part of the board. My R, my F calculated will be equals to summation of this, which is what? Summation of R squared, which is summation of R squared, multiplied by n minus 2 divided by summation of E squared, which is going to be summation of what? Of E squared, which is summation of E squared. Now, it means number I have here divided by the number I have here. Now, but the number here, I will be multiplying it by what? By n minus 2, which is it will be multiplied by in a normal sense, it will be what? Summation of R squared multiplied by 8, which is the 8, multiplied by 8, which is n minus 2 is 8, divided by summation of what? E squared. That is what I'm going to have here. It means I will be having summation of E squared multiplied by 8 divided by what? Summation of what? R squared. That is my this. Now, here, p-value. How do I get my p-value? That is where another work is. My p-value is very sensitive, and you must come from your what? F value. You must come from your what? F calculated. Now, how do I go? I will go to my table of value. Permit me to bring out my table. Okay, this is called statistical table. Can you see? Statistical table. That is our table. Depends on the table, and I'm looking for ANOVA table. Now, I think I don't want this time. I don't have that time. Now, I will come to my ANOVA table. This is my ANOVA table. Now, which is, we call it F distributed. F distribution. Some textbook call it F distribution, how it is on the statistics. Some people call it ANOVA table. Now, on my ANOVA table, which I will come here, these two numbers are very important on finding my what? P-value or F table, F tabulated. Now, what I will just do is that this will be what? We have your p-value on the graph. This is how it always be. On the table, this is how it will always be. V-value will be like this, and 1, 2, 3, 4, and so on and so forth. Now, here we'll be having we'll be having that, and here we'll be having another 1, 2, 3. But when we have some numbers here, that is very important. You can have some numbers here. Please, I don't try to explain this very well that it will be understandable. Now, you come to what? This is of your what? Of your regression degree of freedom. Now, this is of your what? Of your error degree of freedom. Error degree of freedom. Please take note of that. You will now come to the table. You have 1. This is your 1. You have 1 like this. This is your 1. And under 8, you come to where 8 is. This is your 8. Now, on this, 1 under 8, it means 1 under 8. This is 1. Sorry, permit me. This one will be 1. This one will be what? 8. On that 8, this is your p-value. Now, you have 8 like this. This is how the table looks like, because some people do not understand how to check the table. Now, you will now come to 8. You have, this is, in the 8, we have 1.54. We have 3.46. We have 7.57. We have 14.69. Now, this is now your p-value. P-value will now come to under 8.250, 0.100, 0.025, 0.005. Now, please take note of this very well. Now, that is my p-value. Now, I will now come here. I will come to under 8, which is my under 8, 1 under 8, 1 under 8. Now, I will now come to this particular part. Now, and look at the value. P. Now, my F value, whatever I have my F value, if my F value is, for instance, my F value is equals to 5.66. Now, I will now come here. 5.66 is between this and this. Is between this and this. That is my 5.66. Now, 5.66 is my F value. I mean, it's my F calculator, which is going to be 5.66. I'm just so that I'll be able to explain this very well. I will now come here and look at this one. 3 points and 7 points. 5.66 is in between these two numbers. Now, I will now come here and look at it. It means my F value is between what? 0.100 and 0.025. It means it is between this number. If I like, I can pick, let me pick 7.7, 5.7, which is 5.7. Okay, I think my p value will be 0.25. That is my p value. That is my p value. Now, please take note of this. It's very, very technical. Now, in the next part, you have to understand your conclusion part. How do I conclude? Conclusion part is very, very sensitive. Now, the next thing we need to do is that you know the number of your variable. I think in the next video I will explain that because of time. That is I think with this you can see the nature of ANOVA table and the regression analysis. Once again, you are on with Further Solutions Academy. Thanks for watching.